So welcome to the second talk on the third day of UGM 2021. This is Ilari Korhonen from the KTH Royal Institute of Technology. This title, we're very excited about this, Refactoring Kanki, which is an application that he wrote a few years ago towards a modern native iRODS client implementation. Go for it, Ilari.
Oh, thanks. How's the audio quality? Can you hear me good? Or
very good, yep.
Excellent. Okay, so hi, I'm Ilari from KTH. So I work here at our supercomputer center called PDC. And here we are managing this national research data store in collaboration with other universities and national players. But this presentation is about my old project that I started some years ago. And now lately we have been looking into it again with the guys at the consortium, that maybe we could perhaps bring it up to date. Okay, so a little bit of background. So this was started as a pet project by me back in 2014, because back then I was tasked with designing solutions for research IT, especially managing research data at my old university. And obviously then we ran into iRODS because back then the national infrastructure in Finland was based on top of iRODS. So I was thinking that perhaps we build an iRODS grid of our own at the university. And we ran into a problem that there weren't really any that up to date and widely available, as in the sense that availability for all operating systems was a bit of a question for the current graphical interfaces back then. So I started writing my own, and 2015 the guys suggested that maybe I'll come and present this in the States, and then they suggested that maybe we should publish this open source, and the university agreed. So it's been available in GitHub with the BSD license for some years. But sadly, I haven't had much time lately in these last few years to continue with the work. So I've been just randomly, during some times, have been able to do some improvements, but not that much, sadly. So then we got this boost last summer when I was in quarantine. Actually, I was quarantining in Finland in an undisclosed location. And then I suggested to my bosses that perhaps I don't break any systems while I'm in quarantine, so I'll use that 2 weeks for development work. So that's what we did, and we had some fun with the guys and started rewriting some code. So basically we started looking into the latest and greatest developments done by my friends Alan and Corey at the consortium, which are basically, in short, one could say that they are C++17 object-oriented interfaces to iRODS, which are in the future planned to replace all the old C-style APIs in the library. So just a quick overview of this project for those who haven't seen it before. So this is an application written in C++ on top of the Qt framework, which means basically that it's most of the code is already fully portable. Everything that's written on standard C++ and on top of Qt is basically free of any operating system interfaces. So you can compile the same code on Mac OS, Windows, and Linux, and some other Unix operating systems as well, wherever Qt builds. And this application is basically your standard issue graphical user interface for iRODS. You can put files, get files, drag and drop, rename, delete, manage the hierarchies, manage metadata, search for files, search for objects based on the usual criteria you wanna search files with. And in addition, you can actually search data based on metadata attributes because of the iRODS generic query interface. So there's a search integration against the iRODS query interface. And since it's based on the native library, that means basically that wherever the consortium ports their iRODS client-side build, like iRODS I commands, wherever that builds, and wherever Qt builds, Kanki will build as well. And it can take advantage of all the plugins that basically come with the build, like the transport plugins, like SSL, and all the authentication plugins as well. So it's transparent for those. And there are some releases still in GitHub, but unfortunately those are all built for iRODS 4.1. But they seem to work also mostly against 4.2 servers, but there are some cases where some errors might occur, like accessing resource hierarchies and such things like that. So it's not perfectly compatible, the old builds, against iRODS 4.2, but it might be still usable. But anyway, recently we have been trying to get this up to date, and the problem currently is macOS and the building of the iCommands package and the client-side libraries in macOS. And the people at Cyverse, who are probably present here, they have the same problem, and we are looking into it together. But sadly, I haven't had much time to work on this with them, but hopefully we'll have some time to brainstorm about this and maybe get it back on track. So here's an old screenshot. You can maybe zoom in on the dates. It seems that this is from September 2015, but it's how it looked then. So there you can see two windows. The other one is your usual browser window, and the topmost window is the metadata editor. And there you can see that the metadata editor is actually showing a customized view of the actual metadata in the database. So this was an example where I used schema definition for giving a little bit prettier names for the attributes. So if in database it says dicom.something, on screen it will arrange those into a dicom folder, if you will, or dicom namespace, and then give nicer names to those attributes. And also you can write filters for the values that the UI will filter them to the user. So now I should start talking about the future, at least for this application. So as you all probably know, or at least those who have been looking at the development of iRODS, it used to be pure C. So up until iRODS 3.3.1, it was all C. But starting from iRODS 4, it's been an ongoing process of refactoring, and the modern code base is C++ 17. But actually, most of the code in the client library is still pretty much compatible with the old APIs, and there is no dramatic differences in the API calls yet. Well, should I say up until recently. So for some time, the guys have been writing these new object-oriented interfaces that will wrap around or perhaps eventually replace those old school C-callable interfaces. But currently they exist there side by side. And the really cool things are that now we can do things like connection pooling out of the box. And there's also a nice little thread pool management class that's built into the library, which is basically coming from Boost. And this basically enables us to write a lot more parallelism within the client, because now we can schedule tasks that span many different connections to different server agent processes. So that means that we can distribute work to many threads running in the server. And we can even do this nicely asynchronously. And here is a teaser screenshot. I'll also try to give a demo. So the future is, should I say, darker, but hopefully only in a sense. So mostly, as you see, this pretty much looks like the same, but this screenshot has been taken from Linux X11 environment, because this is the latest build that currently only builds only in the Linux environment. So I'll later on give a demo in Linux virtual machine. So let's take a look into the technology changes under the hood. So now Kanki is starting to use the iRODS connection pools and also the iRODS thread pool, which is basically the Boost thread pool, since iRODS builds heavily on the Boost libraries as well, when the standard C++ is lacking something. Eventually things seem to migrate from Boost into the standard, but still there is something that you need Boost for. So what Kanki is doing these days, it's enabled to manage a connection pool of, let's say, n connections, which all are pointed to the same so-called endpoint, or they basically are connecting to the same destination, same server host. And then what you can do is that you can take a connection from that pool and then run a task using that connection and that server agent. And then when it's done, you can put the connection back in the pool. And if you want to run tasks in parallel, which obviously we want to do, we can use the thread pool. So we can write a task that basically does a job for you. And as the guys say, we peel off a connection from the pool for the task and then let it run. And we can do all this in parallel, because the communication channels are independent and they are locked for the tasks at hand. So there's no interference. And one agent process is handling each serving of each request to each worker thread. And then when it's done, it's done. And the second new part is the object-oriented APIs. So some of these are still named iRODS experimental, or they are in the iRODS : experimental namespace. And I guess when they are deemed ready, the experimental will go away. So this would become iRODS file system, iRODS IO, and iRODS query builder, and so on. So things that we have already started using is the file system API, the streaming IO API, and the query builder API. And these basically all replace old interfaces in the Kanki source code that I wrote myself back in the day, and now they all come as standard from the iRODS client library. So I don't need to write my own object-oriented libraries to use in between. And also there is a couple of interesting changes in paradigm. So these days, this thing called ErrorAI seems to be a very, very hot thing, which basically is a paradigm for resource management in the code. Because when you do things the old school way, then when you allocate memory and handle all the allocation yourself and in different places and different ways, there's many opportunities for leaking resources. Basically forgetting to free the resources that you have allocated. So when you're writing things in the ErrorAI way, or as it's also called scope-based resource management, which basically means that you write C++ constructs that basically manage the resources, and this whether these encapsulating objects are either in scope or out of scope. So that determines when the resources are allocated or freed. So it's simple as that. When the objects go out of scope, resources get freed by the destructors. And this basically means that that this all becomes naturally exception safe, since all that happens is during the unwinding of the stack. And soon you will see in some code snippets that in the modern way that iRODS is written, exceptions are all over the place, or at least hopefully not all the time, but there is a lot of catching of exceptions in the error handling process. And then the other interesting change is, for me, this is even more interesting. This is since C++, the modern versions of C++ enable you to use functional constructs like these so-called lambda functions, which is basically an anonymous function as an object that you can pass along, or write the function as a literal value that you actually define then and there. So, for instance, you might consider writing a lambda function for a simple task you want to do. Let it grab a connection of your pool, and then send this lambda function to a thread pool for execution. This works. So here I have a couple of Simplex examples. I hope the font size is big enough, or if it isn't, I can also try to zoom. Can Terrell, for instance, say if the font size is good enough?
It's fine. Yeah, it's your full screen.
Oh, good. So on the left side, you can see an example. So this is all in pseudocode. Don't try to compile this. So this is simplified from the actual code in GitHub, and some unnecessary stuff has been commented out and taken out, and some expressions changed to a more, let's say, teaching kind of format. So on the left side, you can see the old way. And this example is how you would create an iRODS collection. So first you would initialize an old kind of data structure. Then you would lock your communications channel using a mutual exclusion lock. Back in the day, this came from the Boost library. And then when you have locked yourself or acquired the lock, then you can call the old school C standard way, the client API call from the library. And then when you're done, you can unlock. But on the right, you can see how it's done these days. This uses the ErrorAI paradigm. So it acquires a C++ standard locking guard for the mutual execution lock, which means that from the definition it's acquired, and when that thing goes out of scope, it's released. So in between, we can do the thing. And we see that we grab something from the iRODS experimental file system namespace, and we call the modern version of the create collection call, which is nicer and simpler, which also throws exceptions if necessary, and we can catch them. And then another slightly more complex example is the download process in Kanki, which was already multi-threaded in the older version, but in a different sense. So in the older version, Kanki basically, for each download or upload process, it opened up a new connection and assigned that to the download manager thread. So in this old version, you can see that this is the this is the worker thread function that gets launched, and it starts with basically building a list of all the objects that need to be fetched, either data objects or collections. And when it hits a data object, it invokes the download routine, which does the actual streaming. Back then, it used my own version of the streaming library, which interfaced with the iRODS streaming API. But in the later version, each download thread actually creates more threads. Each download manager thread owns a thread pool. And after it has the list, what it does, it basically starts instantiating lambda functions for each data object. You can see the lambda function in the innermost if, after the innermost if statement, if cur obj arrow obj type equals data obj t, you can see that there is an iRODS thread pool post. We're posting something to the thread pool tank, and then we pass a literal function into that thing. We acquire a connection, we check that it's valid, and we run a function, call a function get object, while passing this connection object to this function. And these things get passed into the thread pool, and they are scheduled from there on, and they do their thing. And they communicate to the UI and manage the widgets in the UI, report their status, and then clean up after themselves. And that's it. Last example, there was this incredibly, perhaps the most immature function in Kanki was the quick and dirty Qstat window, for which I simply put a Qt timer, which invoked a refreshing function, which basically did an iRODS query and then dumped the data into the UI. But obviously this was extremely dirty, and if you had some problems with querying the server, you would end up blocking the UI, which is not what you want. So what happens now is that the same timer is still there, but attached to that, we point another function, which basically is sending a lambda function to a thread pool. So the Qt event handler basically calls something that creates a lambda function that puts an executable function in the thread pool that comes from the iRODS client library, which basically does its thing and manages the data behind the UI. And this is done using the modern versions of the query interface. So this all replaces my old replacement for the iRODS query interface. And this is all exception handling, ErrorAI, everything. So you can see that here we build a query, peel off a connection, call query builder to build a query and execute, catch the exceptions and dump the data if it's good. So since we still have some minutes, I could do a demo. I probably need to switch to screen sharing. And share a, can you see my?
Yes. I see the terminal.
Good, and the font size is big enough.
I believe so.
Okay, let's nuke the build. So this thing builds with CMake, and it uses the iRODS CMake build definitions as well as the Qt, so everything just integrates nicely. And we can run a build. Laptop is screaming, but hopefully it will survive.
If you do have Slack open in a different channel, different window, you might be able to see a couple questions, but don't worry about it if that messes up your display.
Let me see, I have a couple of displays here. Slack and in the general.
It says, how is Kanki packaged for Linux? Is it an RPM, for Windows? How is that handled right now?
I have an RPM build for it, but it doesn't really work right now yet. It's for the old versions of the build, but it's pretty quick to bring up to date. So RPMs are fine. So yet I haven't done any Debian packages for Ubuntu, but RPMs build, yeah.
Right. And another question, does it work on Ubuntu 18? Just tried to build from source and it can't find the boost JSON externals.
Yeah, sorry, I haven't tried that yet. So it's probably something pretty simple, but sorry, I haven't tried that yet.
Okay. And then the last question says, is Kanki a maintenance tool or is it suitable for non-technical people to use iROD?
Yeah, it was basically meant for non-technical people originally. So it's basically meant as a simple user interface, but I'm also planning on writing some more administrative functions in it.
Right. And it sounds like there's a clamoring for more screenshots and more pictures.
Yeah,
that's what tells people what it can do without building it.
I can try to find those, but I can also show right now if we have a couple more minutes. So now what it says is establishing a connection pool, and it says connection pool size 16. And now we are connected with 16 connections to my production servers here. So just your average scrolling around the directory tree or the virtual directory tree. It's relatively responsive, I guess. And you can do things like and then you can find that by let's see, what did I don't even remember what I wrote there. Let's add an attribute called UGM, and okay. So if we want to find that from the whole thing, we want to say we want to find a collection metadata, which is called UGM equals rules. Execute. Doesn't sound good. Is it the data object? Interesting. Seems to find something. There might be a bug somewhere. But what I could demonstrate is the download function using the parallel download. So this is not yet the actual new school parallel streaming into the port 1247, but this is actually transferring several files at once. So later on, I plan to configure it so that you can have larger files, open a proper parallel transfer for each file, and then you can do smaller files in a single connection and so on. But that's still a bit of in the works. So we put the thing there. So here you can see that the thread pool is instantiating tasks, and those tasks are doing their work and updating the UI of their state and then cleaning up the UI afterwards. Alan is asking.
Alan asks you if you would be interested. Oh, I see you answered. If you'd be interested in trying out a parallel transfer engine implementation. Sounds like this is ripe for that. Yes.
Yeah, we were gonna do that earlier, but then, you know, life happened.
That's right. That's right. It's been a lot of life happening in the last year.
Yeah. So we were planning on doing that already last summer, but we didn't get there yet.
All right.
Do
we have any other questions from the community here? We've got, I think people are excited about it. We got to, yeah, got to sell it with more pictures, I think is the idea.
Yeah, I can do that.
And we can work with you on packaging stuff too, if that's helpful.
Great. Yeah, we should do that.
Very good.
And get the Mac OS build working again. And then we can package that nicely. As,
that's right.
I had this old build that bundled in the iCommands within the app bundle.
Yeah, so I know that the Mac builds are, you know, specific for each version of Mac OS 2 because so many things move under the covers. So
they are not actually specific for each version, but they don't survive very many upgrades. So
right.
So there is a lifespan of the compatibility of the build, but it's not as long as you would want.
Mm-hmm.
Okay, so we made through that. No errors in the log. So I could just so you can see that there's 16 streams to my server. So I guess I'm done.
Very good. Thank you. It's great to see you, and
yeah,
great work. And yeah, we'll definitely get it out and available into more hands. I think a lot of people are interested in seeing how fast it can go. Very good, sir. Till next time. Thanks.
Thanks. See you.
Bye.